Alright, let's talk about perfect forwarding. So let's say you have a middleman type function which forwards parameters to another function. So here I have a function called call, and what call does is it accepts an arbitrary function for its first parameter, and then it accepts two parameters. And it invokes the function, which is presumably accepting two arguments of arbitrary type, and it forwards these parameters directly to the function. So what is the problem here? Excuse me. Well, the problem is that we're actually restricting ourselves to certain value categories for the parameters. So call is expecting an L value reference for A and an L value reference for B. So in fact, we cannot initialize those with R values, for instance. So look at this call down here to the call function. So we're invoking the call function, we're specifying add as the function we'd like to invoke, and then we pass in A. A is a variable we declared up here, so it's an L value, so we're initializing an L value reference with an L value, and that's perfectly legal. And then add is it's expecting an L value reference for A, so that works out just fine. What about when we attempt to pass in 1? 1 is a literal, it's an R value, and we're attempting to pass it into call, and call for B is expecting an L value reference. We cannot initialize an L value reference with an R value, and the compiler will actually complain if you try to compile this code. So how do we fix this? Well, if we're anticipating that the argument for B will be an R value, then we can define an overload that enables you to, that has a parameter where you can initialize it with an R value. But the problem is then, what if I don't provide the literal for this argument? What if instead I provide it for this argument? So then you have to define another overload. And you can see where this is going. You have to define overloads for every possible value categories of parameters that you want to pass in. And it becomes even more mind-boggling when you think, okay, I also have to define overloads for possible CV qualifiers that could be passed in. And you quickly realize that this is a bad situation, because then you have an exponentially increasing size of your code. So perfect forwarding. C++11 adds perfect forwarding. Now, perfect forwarding is an idiom that refers to being able to completely preserve value category of arguments that get passed into templated functions. So let's look at the new and improved call function. So we have A double ref A and B double ref B. So don't get confused. These look like R value references, but they're actually not R value references. These are universal references, also called forwarding references. Now, they're universal references because we have type deduction going on in front of double ref. And that's how you can identify universal references. Okay, so what's the difference? So universal references, their behavior actually depends on the value category of the argument that gets passed in. So when a universal reference is initialized with an L value, then it becomes an L value reference. If it's, on the other hand, initialized with an R value, then it becomes an R value reference. So let's look at the invocation. Let's look at the invocation of the call function down here. So we're invoking call, and we're passing it the add function, and then we pass it A. So A is this variable that we have up here. That's an L value. So we're initializing the universal reference with an L value. Now the behavior is that A, the type A, this will get deduced to be int ref. So the full type of the parameter A will end up being int ref double ref. So according to the reference collapsing rules, int ref double ref would collapse into just int ref. So that's great, because then the parameter A that we passed a function has type int ref. We can initialize this with int ref, that's fine. It's expecting int ref. So that's great. What about the literal? So the literal presented a problem before. So when we pass in an R value, okay, we're passing in 1 to B, so B is a universal reference, And when we initialize a universal reference with an R value, then it becomes an R value reference. So the final type of B is R value reference. So then when we pass B into the function, that's great because we can initialize this with an R value reference. That's totally fine. Now this does present a slight problem though, and I haven't talked about Std Forward yet, so forget for a second that Std Forward is written here. So if we just try to pass in these parameters directly, then we could potentially have an issue. And this becomes apparent if I swap A and 1. So if I replace A with 1, so that, this parameter right here is receiving 1. So if that parameter is receiving 1, then A is deduced to be int, so the final type of A becomes int double ref, or an R value reference. So then we invoke the function passing in an R value reference for the first parameter. So you actually can initialize an L value reference. This parameter is an L value reference. You actually can initialize non-const L value references with non-L values. And that doesn't really make sense in this context, but in other contexts it's kind of helpful and it prevents errors. But in this context, it doesn't make sense because then we would be modifying a temporary. We'd be modifying a literal, and that doesn't make sense. We don't want to do that. So how do we get around that? Well, we have Std Forward, and what Std Forward does is it preserves the value category of arguments that get passed in. So the problem stems from the fact that A is a named R value reference if we pass in a literal. If we attempt to initialize this with an unnamed R value reference, then that will give us an error. So what Std Forward does is it essentially static casts to an R value reference, and the returned R value reference is unnamed. So the compiler would then spit out an error, and we wouldn't be able to make that mistake. So that's what Std Forward does. So perfect forwarding, it's very powerful because it enables you to do kind of higher order programming where you have functions, invoking other functions with arbitrary parameters, and it enables you to do some very powerful things.